All right, guys, it's 11:06. Let's begin today, day 8 of WebLab. Of course, we'll start with the announcements. First up, I'd like to announce our sponsor lectures. We have one by in Hardin today. It's at 1:30, which does mean that we're moving around lunch. But that's fine. Thursday, we have Akamai at 1 p.m., and on Friday, we have Delph. So if you want to attend these sponsor lectures, make sure you RSVP so you can get an idea of the attendance there. And for these lectures, we'll have raffle prizes, including Apple Watches, iPods, Nintendo Switch. And be sure to come to that in case you might be lucky. And then we have office hours today, 7 to 9 in Stata as usual. And then Project Skeleton. Remember, you can get started on your project already. We have those skeletons provided for you. We have a TypeScript and normal JavaScript one. And please complete the setup steps by Friday before the lecture. And this includes making a render account so you can actually deploy your website so it gets on the internet. And then lastly, we have our milestone 1, which is your minimum viable product, which is a working website, which is due next Wednesday at 6 p.m. You can find that at weblab.is/milestone2. And then let's talk about Delph. Delph is an AI native compliance platform. It helps companies automate and maintain regulatory compliance across frameworks. They eliminate hundreds of hours with this of manual work with intelligent agents that gather evidence, fill questionnaires, and surface insights. We'll be having a speaker, Karun. He's a former MIT student who's now working at Delph, and he'll be sharing his experiences on Friday, where we'll also raffle off prizes, including that Nintendo Switch I talked about. All right, that's it for announcements. I'll pass it off to these young gentlemen for their games workshop.
I'm young gentleman 1.
And I am young gentleman 2.
And we are going to dig into building a game within Catbook. So, look at this beautiful collage of video games. Today we are going to be trying to build one. And what makes these real-time games a bit different from some other applications we will want to build? First things first, it has more complicated game logic and state. And this involves keeping track of every single time what kinds of information needs to be kept track of. So another thing is that performance is super important. As you can see in this League of Legends clip, every single pixel and animation and graphic needs to be very high performance. So this requires us to have some sort of real-time update system. And for today, we're going to use sockets for that. So as a recap of how we made Catbook so far, we have our user, the client, and then the backend, which is the server. And the server processes databases, stores files, manages, runs the applications, and we will also manage and run the game here. Additionally, also authenticating with Google. And we have what we call the game logic and game state that live in the server. And the reason why we want to do that is to provide good maintenance and also prevent the users, the actual clients, from being able to access or like cheat in the game. And also for multiplayer, you need to have some sort of server backend. We will be using HTML5 canvas for actually rendering the display of the game. So what we see on the screen will be a HTML canvas. So HTML canvas is essentially a special HTML element, except you can draw shapes, images, texts all to it. And if you draw it quickly enough, like this, it can look like the canvas is animating. So if you have it continuously update with a new position in a really fast time. That's what the animation looks like. So it can draw stuff really fast and is very performance heavy, and versus React, which isn't really set up to re-render constantly. And for canvas coordinates, we just have a little bit of a difference. The y direction increases when going down instead of the normal Cartesian plane. So we just need to consider that. Okay, let's do some review on sockets, because sockets are going to be really, really important today since we need real-time live updates. So I can just fill it in for you guys. We have sockets that enable fast live communication between the server and the client, and API endpoints for slow data communication. We use the client socket for broadcasting updates. We use the server socket to broadcast live updates to the clients, and then we use the client socket manager to receive updates from the server. So essentially, the server socket and the client socket are exist in the server and client respectively, and then they communicate with each other. We use this syntax, socket manager.getIO.emit, especially the emit function is used to broadcast a message from server to all the connected clients, and we use this event name as our channel and then whatever data that we want to send. So in the context of our game, the data that we will send will be basically just our game state. And for listening to those messages, we do socket.on, and then the event name would be the same channel as where we were trying to receive it from. And when you receive the data, you would do some function with it. So today, we'll require both the server to communicate to the client and the client to communicate to the server. So if something happens, like the player presses a keybind on the client side, then we have to tell that to the server so that the server does some sort of update on the actual game logic or the game state and send something back to update the display of the game. Okay. This will be just a quick demo of what we are actually going to build today. So if you go on weblab.is/example, want to join? You guys can also join. We have our game tag, and once we sign in, we have a basic canvas in which you can spawn your different characters and collect food using your arrow keys as your commands. Ooh, 3 of us. Hello. And I just died. Okay, so after a point, he's gonna get so large, and I can keep spawning back in and keep feeding him, like how people do that in Argario. And it doesn't display on here, but basically he became the winner of the game, and the game ends. So that's that's going to be what we're going to build today. Yeah. Okay. Any questions so far? Great. Okay, so now I'm going to start delving into actually how to build a game. So currently we have our Catbook app, and we are going to add a new page in game. And some context with that is that this is what we have so far. So we have all of our other components in our React and our front end, and we have a login system and the client socket, which is going to be the communication method between this side to that server. And in order to make our game, we're going to add a couple of more things. First thing, we're just going to add our game page. Second, we're going to add an input method. So we are going to do it as just the arrow keys. So up, down, left, right will cause some sort of situation to happen on the game. And then we have the canvas manager, which will be directly connected to the game, and whatever the game tells it to display, it will display. So next, on the server side, we have to have our game logic. And this consists of the game state, which is basically just a representation of information at a current state of the game. So because games are so prone to updates, so there's always going to be something new happening all the time, we keep track of it using the game state. And the game logic side runs the game and also calculates all the changes that needs to happen. So some flow would be represented like this. If we have an input like one of the arrow keys, that is sent to the client socket, which is the method for the client to communicate to the server. So the server socket receives that and tells the game logic to do some sort of change based on our input. And then in the game logic, which is the server center, we will do some update and send that update information back to server socket so that the server socket can communicate back to the client. And when it comes to the client side, the client socket tells the actual game, and then the canvas manager renders that or displays that on our screen. So game state is a term we use for all the information about the game that we need to know. But it's not anything related to how React states are. So make sure to keep those two separate concepts. So in our Agario game, we are going to have a couple information that we need to check or represent in our game state. So the first thing is just all the players, who's playing. And then for each player, we need to keep track of where the location of that player is, the color, the size. And then for the food, we need to know where the food is. And then similarly, what color the food and the size of the food is. And then finally, our winner, based on some max size. So the game state is stored in the game logic because the game logic can access the game state information instantly right there. Next, we have our two ways to communicate. So the first one is our sockets that we talked about yesterday. Sockets provide fast and live updates. So if you have anything in your game that needs instant change and instant rendering, we will communicate that information using sockets. So if, let's say, the player eats a certain food, then you instantly need it to update such that it becomes bigger. And then our second method is through our API endpoints. And that's going to be our slow data requests. So we're going to use an API update to actually just set up the game. But for the vast majority of this workshop, we're going to use sockets for any of the fast updating that we need. So we are going to start. For this lecture, we have 5 or 6 steps, and we recommend that where's the recommend thing?
Okay, so for this workshop, we're just going to be live coding. We don't expect you guys to know any of the stuff that we're coding. So feel free to follow along if you want and like copy our code. But the main part of this workshop is just us live coding, and you guys can follow along later if you want.
Okay. So this first step is just making the front end game page. So this should be pretty self-explanatory, hopefully. And we have cat book, and we just need to add a blank game page with a game page link in the nav bar. So in index, we are going to add a path to, or I need to check out the right step. Do that first. Beautiful. We just need to add a route to our game component. And for practice, what that comes as is we have our route, and within that route, we define the path, which will be /game. Oops. And then the element that we want to run when we navigate to that path is going to be our game. So that should be simple enough. And with that, we need to import the game inside of this file because our game is going to be one of our pages, and that file, game.jsx, represents that page. So we would import game from the path that exists. So since index.jsx is in the source folder, in order to navigate to the game, we'll have to go in components, and within components, it'll be in pages. So dot, which means the current directory, and then components /pages/game. Okay. And then we just need to add game page links in navbar. So in navbar, we have currently our navigation bar that consists of the home, the profile, the chat, and we just need to add another link to the game. And link is imported from React Router DOM. So it basically just takes the HTML A tag and creates it in a React element. So the syntax follows this, in which you have an attribute called to, and this to will be just the path of where that link will lead to. So after you press this game link, you will navigate to the game route. And with that, we'll just have it have the same CSS as the other buttons on the page. So that should give us what we need. So if I do npm start. npm start is the running the server, and then npm run dev runs our client. So you can have multiple clients for each server. And if I click on our localhost and log in, you can see now we have our game link. Oh, it's
the Mongo URL is bad.
Oh yeah, it is. I didn't. That was an issue with mine. Okay. Where was it again? Okay, view.
Check this out. Isn't that the Mongo URL? Low-key cooked. Alright guys, you're gonna watch how to debug your MongoDB database access real time, as Raymond doxes himself to everyone. Yeah, like Loki, this should be working. Try restarting this server. Oh yeah, did you add localhost for access? Security, database and network access. No, it's IP access list on the left. Yeah, and then just add 000. Add IP. All right, guys. This is also something that you might find helpful. For when you're setting up your databases, you want to allow. You have to do like 0.0. Oh, just click allow access from anywhere. Yeah. Okay, guys. Yeah. So pretty much the issue was Raymond's computer has moved to like a different server within MIT's network. So it thought that he was at a different IP address, and basically said, no, you're not allowed to connect to the database. So what he's done here is he's just allowed to connect to the database from anywhere. If you guys wanted to, you could actually go back in lecture footage and steal his Mongo SRV and mess with his database. Did you restart the server? Yeah.
Let's reset the server.
And actually, okay, yeah, there we go.
We can now link to the game page. So it's going to be empty right now, but the goal will be that this is going to be where our game exists. Okay. Does that make sense? Okay. So next we are going to do some basic steps for the game logic and display, and Calvin will introduce that with what he's drawn on, and hopefully that will make sense.
Yep. All right, everyone. Listen up. So we're gonna have 7 files, kind of, that we're gonna be working in throughout this workshop. We have the input, the socket, the actual game component, the canvas manager component, and then on the server side, we're gonna have the game logic, the socket, and the API. Okay. The API, like we said, is going to be used for slow communication. So when the player spawns in, it's fine to like send that message slowly. We could do it with sockets. We're going to do it with API just to show you that it can be done both ways. The sockets, this is going to be for sending player movement to the server, and for the server sending the game state back to the player. This socket is going to pass its info to the game, which is going to pass that game state to the canvas manager. The canvas manager is going to render the current game state. So some games have like the movement locally. That is not the case here. When you put an input, it's going to tell the socket to send that movement input to the server, at which point the socket is going to ask the game logic how to update. The game logic is going to update and send that updated state back to the socket, which sends it back to the client side, which sends that game state to the game object, which sends it to the canvas manager to re-render it. Does that make sense to everyone? We'll be drawing in these arrows as we implement them as well. So.
Okay, so as he perfectly described, we have the client side. So our basic game logic on our client side, that will just consist of the canvas element, and within that canvas element, we are going to draw our player. And then on the server side, we will define our game state, which includes a winner and then the list of players, and then have our server socket, which is the communication method to send updates to the client. So whatever new updated game state needs to be updated or needs to be communicated to the client, we use the server socket. And then we need to spawn a player when we have a client socket that connects. And for now, we'll spawn the player when they're just connected to Capbook. But later on, Calvin will also add up the spawn button, which allows us to only spawn a player when they press that. And I'm going to talk about this React hook called useRef, and we are going to be using that. Using that for our canvas. So in this canvas example, we don't want the certain information about this canvas to re-render every single time we have some sort of update. So like when you take just a normal state, it'll cause a re-render of your component every single time there's some sort of update. And that's why we use the use effect to see whenever a specific state or value or prop changes. So it causes a re-render and then causes all its child components to also re-render. But we use useRef when we want to have something that we can update over time, something to update over time without actually causing full re-renders. So here, this canvas, which is the display of our game, will be continuously updated very quickly. And we don't want that to cause huge renders once again, because that will cause it to be slow. And so we define this reference, canvas ref, so that we can render the canvas on the page and update it periodically without needing it to causing it to re-render. Okay, so first couple steps we are going to do is just set up the basic game logic. So that includes actually the start game function, the updating game state function, the send game state function, and then actually like defining a state. So we are going to do those steps first. So our first step is to git check out workshop ape step 1, which I've done here. And we want to initialize the game state. So if we go to the game logic file, which is going to be okay. Can you guys hear me still?
Okay, so in our game logic, this is going to be the game logic box in the server. So we're on a server side right now. We are just going to create an object for the initial game state. So let's call this game state, and the game state will include our winner, which we will initialize just as null because no one has won, and then the players. So we will initialize that as an empty object because we're going to have all the players within this players object, and for each player we have the shape, the color, and the positions for that. So that's just the object for the initial game state. And next, we will go to line 43. So we're going to initialize a update game state function that's just going to update it whenever we call it. So if we have update game state and just an empty input, we're just going to initialize it as an empty function for now. But when we actually have information to update the game state with, we'll fill it back in. And third step is to have a line for sending game updates to the client from the server. So we would do that, from the client. So that's going to be line 51. It's not line 51. We're first going to have our method for removing the player from the game state. So this will be just removing it based on some ID. And each player will be added to the game. Just ignore what I said. Sorry about that. In order to access the game state and this update game state function in our other files, we need to export them. So when we communicate, for example, our game state information in our server socket to the client, we'll have to access this. So we'll just export them. And then in the server socket, we will actually create the functions for sending the game updates. So first, we'll have the function for sending the game state updates to all the clients. So whenever there is some sort of game state information that we need to send, we'll just call this function. So we'll call this send game state. And we will send the game state using the .emit function. And we are going to do this using IO because we already, IO is the initialized server instance that we've defined in this file. And we will emit that we are sending an update for the game state. And then, so this will send in our update channel. So wherever we receive it from, we'll also call it from the update channel. And then the information that we actually emit or send is going to be the game state. So we've defined the game state in our game logic file. So we have game logic.gamestate because we just exported it from here. Okay. And second, we need to actually create a game loop that emits the game states to all the clients every single interval. So our interval here will be 60 frames per second. And the way we will do that is by using the set interval function that I introduced in our stopwatch walkthrough. So every single second we will be, or every single 60th of a second, we will be sending information. So we will define this function as just start running game. And what this will entail is the set interval function. And we set interval such that every 60th of a second, we will do this certain function within here. So the things that we want to do in here, if you think about it, will be just updating the game state and then sending the game state. So we define update game state in game logic, right? So currently, it is just initialized as an empty function. But we want to send the update game state function. We want to first update the game state and then send that information to the client. So we will update the game state and then send it to the, or emit it to all your clients. And we do this every single 60 times in 1 second. So that will be 60 frames per second. And oops. So we have the Oh, beautiful. Okay. So we do this in this interval. Oh. Yeah. Don't typo. So we have this as our interval, which is 1,000 milliseconds over 60. So every that interval, we will call these functions. So we'll update the game and then also send the game to the clients. And here, we can just start that game. Okay, so functionally, what we just did is we have a way of constantly communicating the game state from the server to the client. And that is very important because whenever you have any sort of update, it can instantly communicate that information using this socket.emit. So next, we want to do the logic for defining the player. So first, we want to have spawn player in game logic, which will just be us adding this player with this certain ID to our game state. So we have our game state, and we just need to add this player with this certain ID to the game state. So if we access the player's dictionary within that and call it by its ID, and we can define this with the position, the radius, the color. So all of that information will be for that specific player with that ID. So in here, we will have the position, and we will initialize the position just using this getRandomPosition helper function we have predefined here, which will just take an x and a y from within the map, and that will be what we initialize it to. So position would be getRandomPosition, and then the radius would be something else we define up here, which will just be our initial radius, so 20. And then the color, we're going to take a random color within this array. So one thing you can do is use the random function to generate a number from 0 to 1, and then multiply it by the size of this array, so 7, and then rounding them down to the floor so that each of these colors is represented by a number. So red would be 0, blue would be 1, green would be 2. Huh? Oh, shit. Wait. 12. All right. Okay. So in order to do that, we'll have our colors array, and then we will index it based off of that process that I described. So we would take the floor of whatever the random number from 0 to 1 times the length, so 7. 7. So some number from 0 to 1 times 7, and then that will be our color. Okay, so we have set up our spawn player, and now we just need to have the remove player function such that when a player is removed from the game, if they disconnect or if they get eaten by a bigger boy, we will remove that player. So we will do that using the delete keyword. So this delete keyword deletes the item that has that specific key. So this ID. So we will delete it from our game states player based off its ID. And now we just need to go in the server socket and call spawn player when we actually just enter the page. So this will just be temporary because later on we want to add the button so that you can press the button in order to spawn. But for now, it will just be here. So our game logic function that we just defined, spawn player, will be called whenever this user is added to the game, or added to the game. Okay, so that was all in server side. So we defined players. We established communication between the server and the client. And now we just need to receive that information in the client and then display whatever we need to do based on what we received. So in game.jsx, so we're outside of the server now. We're going to our React stuff. In game.jsx, we need to just process the updates that the server has just communicated. So we need to do that by calling the socket.on to receive the information, right? So we're going to socket.on the update channel because we had the emit in the update channel. So this, again, this function sends an update of the game state to the client, and then here we are receiving that update from the server in this client. So the information that we will receive will be the updated information. And we're actually going to take the received information, so our the updated state, and then actually run a certain function based on that received input. So if we received update, we're going to call this function, so process update with that update. And remember, the use effect calls in the initial render of the game. So this will happen instantly, and the socket will continuously exist while the game is rendered. And then when we have to dismount it, then we will return our final function, which will just be to turn the socket off. So this will just happen when like the game is over. Keep this arrow is not pressing. Okay. And now for our process update function, we are going to just call this draw canvas function, which we will define in Canvas Manager, which will be our next step. So this will actually draw the canvas on our Canvas page. So that leads us to our final step, 1.6, where we will actually draw the player on the canvas. So this function that we just called will just consist of calling another function that we defined for you here, fill a circle, and it basically just fills a circle at a specific XY coordinate with a certain radius and color. And you can see that's just done in this function. So we will call fill circle. But now, since we are in the canvas coordinate system, as I was describing earlier, like how the y-axis is increasing when you move down, we will have to convert the coordinate. So we convert the coordinate over here in this function. So we have our new x and y coordinates based on our canvas coordinate system. So when we fill it in, we will just fill in using the inputs that we need here. And this should just fill in a circle for us. Finally, we have to actually draw the players using the draw player function. So draw the players in the draw canvas function, because in here we draw the canvas when we process every update. And really important, keep in mind, is that the canvas canvas is a reference. so it doesn't cause a re-render of the game entirely whenever it updates, because it's a use ref right here. So in draw canvas, we need to just add a line such that we draw the player, or draw a player for each player. So we have object.values, which takes all the players. And for each of them, or object.values of the draw state players, so it takes each of the players. So for each of these players, we will draw that player with its certain x, a certain y, certain radius, and certain color. And remember, the reason why we can just do this is because the information about the draw state is our game state. So we've defined in game logic our game state with our players, and within the players, the position, the radius, and the color. So that's how we're accessing it with p.position.x, p.position.y, p.radius, and p.color. So if we rerun our localhost, log in, and go to our game page. Let's see. So we have undefined. Okay. Oh, it's like game logic. Okay. Hmm? Okay, so for this function, we will have our game state and our canvas ref passed in. So here we have the updated game state, and then we will pass in our canvas ref, which is defined as a reference, so that whenever it updates with a new state, it will not cause a re-render. So with that, it should finally work. So there you go. We have our player. And every single time we reload, the player is initialized with a random color and a random position, x and y. And that concludes that first step.
All right, guys. Thank you, Raymond, for that. Real quick, we have been sitting for about an hour, and lunch is going to be a bit late today. So I'm just going to have you guys all stand up and stretch. If I don't see every single one of you stand up, then I'm failing all of you. It's really good to get the blood flowing, especially for such a long lecture like this where you're not really like doing anything, you're just kind of sitting and watching. It's just good for mental thinking. All right, and we already did the demo there. I'll leave this up for a bit. All right. Now, of course, constantly clicking refresh and hoping that you spawn in a new position is not a very great way to move around in a game. So we're going to be adding movement and processing inputs. So what that's going to look like is something like this, where if you press the arrow keys on your keyboard, then you'll move around. And guys, if you have played any sort of game, this is literally the worst possible way to do movement inputs. Because like, okay, you know how when you press a key on your keyboard and you hold it, right? It'll do like one letter at first and then it'll spam it. That is the movement for this game. It's like the worst thing you've ever done. Anyways, we're going to do moving now. So what that's going to look like is if we go over to this here, we're going to be listening for inputs. And when we receive an input, we're going to tell the socket to put that input to the server. And the server is going to say, hey, how should I process this input? And it's going to process the input. And then it's going to be sending the updated game state. So you're going to see yourself moving around. Okay, does that make sense? And then also, where is it? In the actual game file here, this is our game element. This is where we're going to put our listener, right? Because you need to be listening for inputs. JavaScript is not always listening. All right, so of course, just to make sure we're all on the same page, we need to git reset hard and git checkout workshop 8 step 2. Bada bing, bada boom. Okay, so our first step is to create our function to send movement data to the server. So that's going to be in client socket here. And the way we're going to do that is with our export const, and let's just call this like move. And this is going to be our callback function, which takes in a direction, because we're going to be calling this later. And all it's going to do is take our socket, and it's going to emit a move command with the direction. So this direction here is literally just going to be a string, up, down, left, right. And the reason that we encode it like this is because we don't want someone to create a hacked client which lets them teleport around the map. Granted, like they could just send a bunch of socket move commands. Anyways, our next step is to go into our server socket here, and where is it? Down here, we need to actually tell our server to do something when we move. But for now, we're just going to do socket.on move. So when it receives a move command from the socket, it's going to call some callback function, which we're just going to leave undefined for now. Okay, and let's make sure to save both these files. All right, our next step is going to be in input.js here. We actually have to import our move command from client socket. So what that's doing is it's letting our input call that function which sends the socket request. So import move from /client socket, like so. And then in here, we see we've already started defining it a little bit. But whenever our input, like a key is pressed, it's going to be passed in an event. And that's just going to be this E parameter here. And that event object is going to have a key called key, which is just a string representing the key that's been pressed. So we want to broadcast our move message with up when the arrow up key is pressed. And we want to do that for all of our directions I actually didn't have to delete all of that. So when our arrow down key is pressed, of course, we want to broadcast down. When our arrow left key is pressed, we want to broadcast left. And lastly, when our arrow right key is pressed, we want to broadcast right. Okay. So this is all fine and dandy, but we actually have to do something. We actually have to listen for these keyboard inputs because just writing this callback function isn't going to do anything helpful for us. So for that, we're going to go to game.jsx here. And when our component is mounted, we want to call window.addEventListener. And window is one of those JavaScript variables that's always part of the runtime environment, at least on the client side. And it's just representing the current window. So you'll always be able to write window.addEventListener in any piece of JavaScript that you're writing on the client side. And the event listener that we are going to be calling is called key down. And it's going to be handle input as our callback function. So notice you do have to import handle input here. So what this does is that anytime any key is pressed while the user is focused on the window, it'll call this callback function with an event object passed in. And that event object is going to have a key called .key. That's the key that's been pressed. And of course, when we dismount the component, like going to another page, we don't need to be listening for those key presses anymore. So we can window.remove event listener, key down, handle input. And an important thing to know is that we are passing in the same function here, which is how it knows that this is the callback function to remove. You might have multiple key down listeners, and in that case, like the window doesn't know which one to remove. So you can't just define your callback function directly here. You have to define it somewhere else and then reference it here so that the window knows the correct one to remove. Okay. And then finally, or probably not finally, but in our server socket, we're going to actually define our callback function here. So this is going to, remember, we broadcast our direction. So our socket is going to take in the direction. And we are going to get the user that is sending this move command. And if they're logged in, right, because we don't want random people to be sending requests, then we can do gameLogic.movePlayer user.id direction. Like so. Okay, so what this callback function is doing is that whenever we get our move socket command, it's going to call this move player function defined in game logic, and that's going to be our final step, actually defining the function for the specific user. So this is our final step for getting movement working. If we go into game logic here, we can see that we have move player. This is going to take in our player ID and direction. All right. So again, this is like the worst possible way to implement movement in your game. But we're just going to loop through all of the possible movements, which is going to be up, dir equals up, like this. And if the direction is up, then we're going to take our GameState.players with that ID, and up here, This just checks that the player exists in the game. If they don't exist, then you just don't do anything and you return early. We take this player, we take their position, and because they're moving up, we're going to take their y value and add it by, let's just define const speed equals 10. You'll see that in the future steps, these are just manually set to 10. In general, it's good coding practice to define like some speed earlier. We're just going to add their speed, like so. So this takes their y position and it increments it by their speed. So we're just going to do this for all of the other directions. Down, of course, is going to decrement our y position. Left is going to decrement our x position. And right is going to increment our x position, like so. And then let's just make sure to save all of our files. Okay. Now if we go to our game here, we reload the page, and we log in, we have our player, and if we press our arrow keys, they can move around. Wow, guys, isn't this so much better? Oh, yeah, I see we've got a couple of questions. Yeah? Mm-hmm. Yes. Yeah, great question. So in our game state, we keep track of the player's coordinates with the standard like Cartesian coordinates that we're all used to. And if we go into Canvas Manager right here, we have our convert coord. So this converts our world coordinates to canvas coordinates. Yeah. So yeah, so that's being called here when we're drawing the player. So this lets us think about our game in standard Cartesian coordinates that we're used to. So like we say, oh, plus y is up, minus x is left, right? This lets us think about it normally. And then we only worry about converting it to those other coordinates where plus y is down. We only worry about that when we're drawing it here. No, this is kind of an arbitrary choice. If you chose your coord, yeah. Yeah. Mm-hmm. Did I? Wait, if we go into game logic here. So if the command is up, then we take the y position and we add to it, which is moving up in Cartesian. And like, yeah, in our game state, everything's kept track of in standard Cartesian. And then only like in the final step when we actually render it, is it put in the other one. Yeah, we have another question. Uh-huh. Great question. So for my game, when I took this class, you have basically a map of keys like that are currently being pressed. So if someone is like pressing the W key, then in this key map, W would be set to true. And then like every frame, you send this map of keys that are currently being pressed to the server, and the server processes updates based on that. And then yeah, and then it updates it. And to update your map, you want your key press or your key down. I think it's key press listener, which only activates when the key goes down for the first time. And you also want your key up listener, which only activates like when you release the key. So that's the only time that you should be updating your key map. And then you just have a set interval that's constantly sending it to the server. So this like lets your server update based on the keys that are being pressed every frame of the game. Did that make sense? No, technically, if you were to like spam keys, yeah. So this move or this move player is being called whenever any key is pressed. Or yeah, I guess whenever any of the arrow keys are pressed, yeah. Uh-huh, exactly. But then it's only being re-rendered every frame of the game. All right. Any more questions? All right, Liddy. So I just did the demo there. Moving on, we're gonna add eating food to our game because that's kind of a classic piece of Agar.io. You start off as the same size, and then you eat food, and then you can eat other players. Which, if we have time, we'll implement that as well. So you can see here we have Raymond eating a bunch of food and growing in size. So we're going to be implementing Raymond functionality to our game. So what that's going to look like is this. You can move around, and every time you eat a piece of food, you grow a little bit bigger. Conservation of mass does not exist in this world, so a tiny piece of food always increases your radius by a constant amount. Okay, so these are the steps we're going to be taking. And this is where they're going to be happening, and I'll explain these as they're happening. But pretty much the only thing we have to do client side is actually render our food. So on the client side, we're going to be rendering our food. Everything else is going to be happening server side, specifically in game logic. So we have that handy dandy function that Raymond defined earlier called update game state. So what's going to happen is every game tick, we are going to make sure that there's enough food, because there should always be 10 pieces of food. And then we check that players can eat food. We feed them the food. And we remove the food if the players did eat the food. And then we just loop. Yeah, it'll make more sense when we're implementing it. So of course, just to make sure that I'm on the same page, I'm just gonna, git reset hard, and then git checkout to step 3. Okay. So to get started, we have our game state here, which has our winner and our players. And we're also going to add food. This is just going to start as an empty array. Boom. All right, we're done with step 1. Not actually, though, because we need to, where is it? Mine's 75 here. We need to add our spawn food function. So this is just a function that when we call it, it spawns a food at a random position. And fortunately, food is very similar to players. So we can actually just copy this. But instead of taking our game state, we're going to do game state.food.push. And put that there and then that there. So what this is doing is it's just adding a new object to the end of our game state. And the object is going to be food with, of course, a random position. The radius is going to be food size. And it's also going to be a random color. So hopefully this spawn food function makes sense to everybody. We just initialize it to a random position, random color, and we give it this small food size radius. And then finally, we need to actually render in our food. We need to tell our canvas manager what food is. So for this, we can do our draw state dot food dot for each, and we're going to take our food. We are going to draw a circle with our context. And then, actually, we draw this exactly like our player. It has the same fields. So you can just paste this in. And I know I've talked about this before, but you can actually alt-click on multiple places and then edit all of them at once and type at the same time. So super helpful shortcut. Okay. And then this should be all we need for rendering in our food. Oh wait, semicolon. Guys, I'm pretty sure the semicolons are optional in JavaScript. Correct me if I'm wrong. But like low-key, it's fine if you forget them. I don't know why they made JavaScript like that. Okay. So this is all fine and dandy, but we don't actually spawn in our food. Well, actually, okay. I think our next step is to compute the players eating food. It's going to be in game logic. This is going to be compute players eat food. Okay? And fortunately, we have a little helpful function here that we already defined called player attempt eat food. And this just takes a player's ID and it takes a food object and it checks if the player is within distance to eat the food. And if they are, then it increases the player's size. So the way this works is this like OG programmer from about 500 BCE named Pythagoras. It just uses his distance function. You can see there on line 32. Yes, question. That's very helpful. Thank you, Amos. Yeah. You could use math.hypotenuse, I guess. Anyways, we don't care about that right now. For now, we're going to compute eating the food in the most inefficient way possible. Does anyone have any guesses what the most inefficient way possible to compute players eating food is? Come on, guys. I just need one hand. Yes, Amos. Exactly. Attempt all pairwise eating between each player and eat food. That's exactly what we're going to do. So we're going to take our, wait, this should be, I want to say, yeah, object dot keys of our game state dot players dot for each, and this is going to be a player ID. And for each player ID, we're going to take game state dot food dot for each food, and we are going to do player attempts eat food with our player ID and that food object. So if you guys are implementing your own games, this is like not the way to go about it. There are absolutely more efficient ways. I think like one is like quad trees. It's like you can put the food in like each cell, and then it's like you can also hash the position of each food. Anyways, this is like not a very great way, but fortunately this is just an example game, so we don't actually care. Next up, we need to actually remove our food. When the player eats it, because otherwise they would just keep eating the same food over and over and growing infinitely in size, much like Raymond. So the way that we're going to remove food is, does anyone have any guesses of how we're going to remove food? Because remember, it's an array. We can't just look it up with a key and use the delete keyword like we can with a player. Any guesses? Not Amos? What's the most inefficient way we could do this? Not Amos. Guys, I need someone else if I'm going to continue. Yes. Exactly. We iterate through the entire array list for the corresponding food ID, and then we delete that. But we can't do that directly because JavaScript arrays don't have a delete or remove keyword, to my knowledge, and .pop only pops like the first or the last element. I forget which one. So what we're actually going to do is take our GameState.food and we're going to set it to our GameState.food.filter. Okay, and what do you guys think our filter function is going to be? It's going to be our, wait, we can't name this F. Let's just call this food. And what it's going to return is food is not equal to the food that we're trying to remove. So what this code is going to do is it's going to set our array to a new array which contains every single food except the one that we're trying to remove. And because we want to do like an object comparison and not a reference comparison, we need to use this not equals equals, like so. Okay, and then the last step of this is to make sure that there's enough foods. So check enough foods is going to be a function that we're going to define here, which is pretty simple. If GameState.food.length is less than 10, then we're just going to spawn food. And technically, this does only spawn one food per time that it's called, but we're running at 60 frames per second, so like all of the food is going to spawn in a sixth of a second, which like is fast enough for us. And then finally, in update game state, we're going to implement our 2 lines. Check enough foods and compute players eat foods. I'm going to save that. And then if we go back to our cat book here and we sign in, okay, and we spawn in, you can see we have all of our foods. And let me just go to the demo slide here. We have all of our foods, and if we move over a food, we grow in size and a new food spawns in somewhere else on the map. Like so. Well, guys, this must be how Raymond feels when we go to Hot Pot together. Okay, very lovely. Do you think we have enough time for this, Raymond? Eating other players? Yeah. Okay, guys. Because lunch is a little bit later today, we do have time to do this step, which is eating other players. So this is actually just going to be really similar to eating food, because remember, our player object is stored very similar to our food object. So just to make sure that I'm on the same page as everyone, actually, like you guys are low-key not even following along directly. But this just makes sure that all of my code is in a good state. Okay, so for eating the players, it's going to look something like this. And unfortunately, we're not going to be able to test it today because we would have to like open multiple windows. If you guys have a multiplayer game that you are making for your project, it's super helpful to get a burner Google account and then open a new tab logged into that Google account so you can test localhost, and it'll be like 2 separate computers, except it's actually just 2 of you. So the way this is going to look is we're going to fill out player attempt eat player, fill out compute players eat players, and then call remove player on each eaten player, and then update the game loop. So this is almost exactly like eating food, except it's with players. All right. So let me just check here. We have player attempt eat players. And the way this is going to work is we have to check the radii of player 1 and player 2. If player 1 is bigger and player 2's position is within the radius of player 1, then we want to eat them. Fortunately, pretty sure we can just yoink this code. And do this. So we have our player 1 position. This is actually not going to be our food position. This is going to be our player 2 position. And we can just copy this, put it in here with player ID 2. And let's just copy this here. This computes our distance between them. If the distance between player 1, or Yeah, if the distance between player 1's center and player 2's center is less than the radius of player 1, and just to make this fair, we don't want it to be an instant kill when we touch them. So we're just going to delete this. So if the center of player 2 is within player 1, wait, actually, low-key, I think we do game state dot players PID2 dot radius. Okay, yeah. Sorry, this is actually more fair. You have to be completely like enveloping the other player to be able to eat them. And theoretically, if player 2 is larger than player 1, then this number would be negative, and the distance will never be a negative number. So you don't have to really worry about this. We just want to make sure that the player size is strictly greater than the other player's size, though. Like so. This check is kind of redundant, low-key. Because again, like this is a strict distance has to be less than. So if the player is in exactly the same position as another player with the same radius, then it'll eat them. And of course, instead of remove food, we're going to call remove player PID2. And then instead of food size, there's going to be the other player's radius. Nom nom. Okay. Next up, you guys saw how we did it with the players. Now we need to do compute players eat other players. So in here, we can just call our new function player attempt eat player PID1 PID2. And this just checks that we're only trying to eat players that are different from each other. Wait, actually, I don't think this has that check. I should probably add that check somewhere. Yeah, let's just make sure that if PID1 is equal to PID2, we just return early here. So a player never tries to eat themselves because that check would always return true. Wait, no, they'd be the same radius. It wouldn't actually matter. Oh, I think this is supposed to return PID2. Yeah, because multiple players can be eaten on the same game tick. Wait. NGL, I'm not really sure what the solution code has going on here. I think this can just be remove player here of PID2. Yeah, TS Loki should be fine. Go to the next step here. All right. And then finally, in game logic, if we go into our update game state, we can also compute players eat players. Okay, I think that the code that our answer key had here basically added all of the eaten players to a list. And then at the end of the game tick, it removed all of those eaten players from the game. So this makes it so that like once a player is eaten. Oh! Okay, actually, I think I know what it did. You can't update a list concurrently while you are for each looping through it. So that's why they instead had a players eaten like array. Yeah. They have this players eaten array. Players eaten dot push PID2. Yeah, remove player ID. Okay. Sorry guys, that's what's actually supposed to happen for eating players. Unfortunately, we can't really demo this one because I don't have friends. Oh, yeah, question. Oh, you mean player 1 is the one who's trying to eat. We do. Right here. We take player 1 and we take their radius and we add player 2's radius. And then we declare player 2 as eaten. Good question though. Any other questions? Okay guys, last step I think, which is respawning and winning, where we're actually going to make the game replayable because currently, like if you get large enough, eventually like you'll be big enough that every food that spawns will spawn inside of your radius, and you'll just infinitely grow in size, much like Raymond at the hot pot buffet. So what that is going to look like is real quick. We have our two ways to communicate with the server through sockets and APIs. And we're gonna make spawning happen with our API, just to show that you can do it both ways, and also because we don't really need speed. So in game, we're gonna have a button that when you press it, it sends an API request to the server. And I like low-key don't like the way that this is implemented, but that API then calls the function that we've defined in server socket to spawn in a player. And then that goes to game logic and it adds the player to the game logic. And then all game updates will be sent to the server socket or the client socket of the player that we just spawned in. So this is kind of what I just described. Like when you click the button, it tells it to spawn a player. All right, this one's a bit of a doozy. As always, we're going to get reset hard and get checkout to step 5. What? All right. Starting off, in server socket, we currently, I think it's right here, where do we, here, spawn player. We do this whenever the socket connects. We should remove this line and put it in our add user to game. Okay? So now we have an add user to game function defined within the socket. And then, as always, we need to also call gameLogic.remove player user.id in our remove player or remove user from game. We also need to remove our line of code here, and then I think that's it. We're just moving our functions around to be a little bit more organized and also allow us to call them from api.js. If we actually go into api.js here, what we're going to do is we're going to add a new endpoint right here. So that we're going to have our spawn endpoint and our despawn endpoint. So that's going to be with router.post, because this should be a post request. Although I think, like I said earlier, it doesn't actually matter. Like there's no functional difference between post and get requests. It's just convention. So our post request is going to take a rec and a res, and it's going to return. Well, it's not actually going to return anything. First, it's going to make sure that they're logged in. And then it's going to take our socket manager and it's going to call this add user to game function that we defined here. And then it's just going to res.send. We just send nothing. Okay, so this is our API endpoint for spawn. Next, we're going to add our API endpoint for despawn. And this is just going to be remove user from game, like so. And we don't actually need to send any info back, because this is all just spawning them in like on the back end. We already are like listening and sending the updates if they're spawned in. Okay. Next up, we need to add our button to actually spawn them in into game.jsx. So I think that's going to be here. The on click for our button is just going to send our post request to /API/spawn. And we actually don't need any params for this because the user is already included in the request if they're spawned in. Oh, wait. And also our, yeah, okay. This is chill. Lastly, actually not lastly, but in serversocket.js, whenever they disconnect from the socket, we need to remove them from the game. So I think it's right. Yeah. Okay. On disconnect, we need to call our remove user from game here. And then in game.jsx, back here, you might notice that our button here is actually dependent, like its existence is dependent on if they're already spawned in. So in our, where is it? In our use effect here, when we're adding the listener, when they close or tab out, we should despawn them because we don't want them to stay in the game when they are like on another page. So we're just going to send our post request to /API/despawn with our blank body here. And then lastly, in gamelogic.updateState, where is it here? Oh wait, I think there's another thing in server socket we had to do. 5.4? Okay, yeah, wait, we did. Okay, in gamelogic.updateState, we should just add our check win here, which we already defined here, which just loops through all of the players and it checks if their size is greater than the max player size. So this is like the point of no return. Like they're so big that there's no hope of any other player beating them. Then we add them to the list of winners, and technically there's this race condition here where if the winners.length is like 2, then the game will keep going. So if they become greater than 200 on the exact same tick, fortunately this will probably never happen, so we don't have to worry about it. And then finally, in game.jsx, we actually want to show who the winner is. So this is going to be a winner modal, which is going to be a state that is a JSX object. Winner modal set winner modal. Use state, and this is just going to start off as null. And then down here, we're just going to uncomment this line of code. I'm not going to lie. We just didn't want to have to type it all out, which is why it's just commented. But I'll explain what it does. So remember, the update that it receives is just an exact copy of the entire game state. And on our server side, we've updated our game state with a winner if there is a winner. So if the update has a winner, then it sets our winner modal to just this box that says the person is this or the winner is this person. And otherwise, it's going to constantly set our winner modal to just null, right? Because we don't want to display it if there's no winner. Yeah, so this is what this line of code does. And then you can see if we scroll further down, we actually need to display our winner modal. What the? So what that's just going to look like is we have our winner modal here. If this is null, then it just won't display anything. Okay, that should be all. So if we actually go to our game now, and we reload, respawn, sign in, spawn, and we collect enough food. Sorry guys, I know this is painful to watch. Actually, low key, if we go into game logic, we can just set our max size to like 30 or something. Max player radius, 30. This should get the point across. Let me spawn in. Okay, guys, isn't this so lovely? This pop-up will actually stay on our screen for the rest of time because on the server side, we never reset the winner. So if you guys were implementing this in your own game, and also the way that this is implemented in catbook.is/example, after a winner is decided, it sets a server timeout. So after like 5 seconds or something, it sets the winner back to null, and that will update it on everyone's client side. Okay. Additionally, we did clean up in step 5.4, where we made our spawn in, real quick, where we made our spawn in happen with the button and the API request. The reason for this is that whenever we have a client join the game, we want them to be able to like choose when they spawn in, and we also want them to be able to respawn when they die. We want that spawn button to appear again. So by making it an API request and a button that they can click, this lets them like respawn rather than just like reloading the page every time they want to play. Okay. So back to recapping with the diagram. We have our path 1, which is here. I'm just going to make this the full screen again. Yes. Oh. Okay, we have our path 1, which is the keyboard inputs. So this starts over here with our keyboard input. We listen for our keyboard inputs by adding our listener to the window. And when we receive an input, we send a message through the socket, which then goes up to the game logic, and the game logic then updates our player's position. For path 2 and 3, that's going to be our game ticker, which is on the server side. We're going to have just every frame, we send our updates from game logic, we send the game state to the socket, which then sends our update like socket message to the client socket, which then sends it to the game object, which then sends it to canvas to re-render it. We also have our spawn player button, which lives in here, and it sends an API request to the server, which then tells the socket to spawn in the player, which tells the game logic to actually spawn in the player. And then finally, we also have a listener for when they connect or disconnect from the game. Because if they close out of the window or go to another tab, we want to like tell the server that they actually left the game. Okay. I know that was a lot of content, so please feel free to go back and review it in the Panopto. We'll post the lecture videos later today. But now Capbook is complete, and you guys can play it. We got a couple minutes before lunch, so maybe if you guys even want to play Ripoff Agario on capbook.weblab.is, you can do that. I think Lucas has some announcements, though. No? Oh. Yeah, you can also see the final product if you get checkout workshop 8 complete. There's some extra features on weblab.is/example, such as sprites, like we render like actual sprites instead of solid colors, which you guys will probably want to do. Yes, question? TypeScript lecture? Yeah. Got moved to the end, unfortunately, but also server auto reset, extra styling with CSS. And also there's map bounds, because currently I'm pretty sure you can just like move completely out of bounds, at least for the code that we implemented. There's nothing actually keeping you within the game. All right, we have some quick fill in the blanks for you guys as well. What enables fast live communication between the server and the client? I'm going to call on a different person every time, so I would like if I could get hands. Starts with an S, guys. Yes. Sockets. What is for slow data communication? It's something E. 2 words. Yes. Yeah, exactly. API endpoints. HTML blank is a good way to render animations on the front end. This is an HTML element, like paragraph or button. This one is called, yes, exactly, canvas. E something blank on the client allows the website to take in user input. This one's pretty tough because I only mentioned it once. It's what we added to our game component here. Yes. Yeah, actually, that's exactly it. Event listeners on the client. The GS stored on the server is where the ground truth of the game should be stored. Someone new. Yes. That is exactly correct. The game state. And then upon a component U something, the event listener disconnect, or a client socket D something, we should clean up the user from the game. So this is the player leaving the game. Someone new, guys. On a component U something, what do you guys do when you get off a horse? Yes. Unmount. And then on a socket, blank. Yes. Dismount. I think it's disconnect. Yeah. All right. So these are the main takeaways from today's lecture. Do we have lunch in the back yet? It's apparently getting set up and almost ready. Yeah. So you guys have made Gamebook. Thank you for coming to our TED Talk. Please leave feedback, weblab.is/feedback. I know this lecture went really fast, but please feel free to reference the files when you guys are making your own games. I think that our food is here, so feel free to get up and go get some lunch.